Hello, and welcome. Today I will be telling you about the Oregon State University 2025 Capstone Architectural Lighting and Design Software Group, and how they developed their project over the course of the academic year. The topics I will cover are the members of the team and our unique skill sets, the parts of the project that we love to be a part of, the results of all of our work over the course of the 9-month capstone program, and the tools that we used to complete our project. Let's get you introduced to the team. We split our project group into two teams, front-end and back-end. One of the backlog items that our group was tasked with was a UI overhaul, so that was the primary objective of the front-end team. The back-end team had several implementations and improvements to make on the app, including improved error messages, image previews, and tooltips. Starting with the front-end team, Art and Lonnie played a major role by handling most of the UI implementation after the prototype was finalized. He put the Figma prototype into code and implemented it with the framework of the project. Lou Fluke contributed significantly to the design process by working on the Figma prototype for the UI overhaul. Maddie Thompson also worked on the Figma prototype, ensuring a cohesive and user-friendly interface. Maddie and Lou worked concurrently on the Figma prototype, meaning that there were two perspectives and many alternative designs throughout the process of creating the UI overhaul. Now on to the back-end team. Colin Cohn was responsible for implementing on hover tooltips, clarifying error messages, and adding a loading bar to improve the user experience. Emmett Carter took the lead on communications with our project partners and assisted with both UI implementation and debugging. Sam Kroll focused on developing an advanced mode for the app and worked on integrating it with our newly implemented features, while also helping with UI functionality. Together, these teams brought the technical foundation and user experience of our project to life. Now, let's discuss what we enjoyed about this project. We spent 9 months working together as a team on this project, a journey filled with learning, problem-solving, and collaboration. The OSU Software Engineering Capstone gave us the opportunity to take on a real-world challenge, and we truly gained so much from it. One of the most valuable aspects was project management. Throughout the project, each team member had the opportunity to take part in planning, organizing, and coordinating tasks. We learned the importance of setting clear goals, establishing timelines, and communicating effectively, especially when things didn't go as planned. There was a lot of trial and error, but that was part of the learning process. Whether it was through weekly stand-ups, progress reports, or design reviews, we learned how to keep everyone informed and aligned. It really helped us develop a sense of accountability and teamwork, which are essential skills for any engineering career. Next, we gained a lot from our software engineering experience. This capstone was our chance to step beyond the classroom and apply what we've learned in a hands-on setting. Each of us got to dive into areas that genuinely fascinated us, whether it was UI design, front-end development, back-end integration, or debugging complex interactions. And because this was a real project with real stakeholders, the pressure was on, but in a good way. It pushed us to improve our coding practices, collaborate better, and ultimately, grow into more confident engineers. These are the kinds of stories and experiences we're excited to share with future employers. We also thoroughly enjoyed exploring new tools. The world of software development is constantly evolving, and this project gave us a chance to get familiar with tools that are widely used in the industry today. We worked with Figma for UI and prototyping, React for building responsive interfaces, and Tori for creating cross-platform applications. Learning to use these tools effectively took time and effort, but it was incredibly rewarding. It gave us practical, hands-on experience that goes far beyond what we'd typically get in a classroom environment. Finally, one of the most unexpected but rewarding parts of this project was learning about a new field, architectural lighting and design. Most of us came into this project with little to no background in architecture or lighting systems. But that quickly changed. We got to sit down with our project partner, ask lots of questions, and learn about the tools and processes architects use when designing lighting for buildings. It was eye-opening to see how our software skills could be applied to such a specialized and creative field. It reminded us that as software engineers, we have the opportunity to contribute to projects that span across many disciplines, even ones we never imagined working in. All in all, this capstone project was more than just an assignment, it was a truly transformative experience. It helped us grow not just as engineers, but as collaborators, communicators, and problem solvers. And honestly, what's not to love about that? So, after all of that hard work, what did we accomplish? To start with, we inherited this project from a previous Capstone group. This wasn't a project built entirely from scratch. It's actually been in development for a couple of years, and we were tasked with picking up where the last team left off. That meant diving into an existing codebase, getting up to speed with their work, and figuring out how we could take the app to the next level. From there, we contributed to the app in several meaningful ways. We didn't just maintain the status quo, we improved on existing features, added entirely new ones, and made adjustments based on ongoing feedback from our project partner. Everything we did was centered on enhancing the app's usability and making sure it aligned with the needs of the target audience and the goals of our stakeholder. At the same time, we realized that there is still more to do. While we made great strides, we also recognized the importance of setting future teams up for success. To that end, we focused heavily on documentation. We wrote detailed comments in the codebase, clarified functionality where needed, and created a project backlog outlining what still needs to be done. This will make it easier for the next group to pick up right where we left off, just like we did. In short, we've made real progress, not just in terms of development, but in ensuring the long-term sustainability of the project. We briefly mentioned tools in the last slide, now let's dive more into how we pulled this off. We've chosen a complementary stack of technologies, React, Next.js, Tori, and Rust, each playing a crucial role in the architecture of our solution. Let's begin with React. React is a widely adopted JavaScript library developed for building user interfaces. Its popularity stems from its flexibility, performance, and the way it simplifies complex interface design through a component-based structure. In our project, React serves as the foundation for creating a dynamic and responsive user interface. It allows us to break down the UI into reusable components, making development more modular and efficient. This means changes to the interface can be made quickly and consistently, without affecting the entire system. Building on React, we incorporate Next.js, a powerful framework that extends React's capabilities and introduces a suite of advanced features. Its built-in routing system is intuitive and scalable, simplifying navigation structure and improving maintainability as our application grows. With Next.js, we're able to build full-stack applications with ease, all within a cohesive framework that supports rapid development and robust production readiness. As we move beyond the front end and into the back end, we turn to Tori. Tori is a framework that enables the creation of lightweight, secure desktop apps using familiar web technologies like HTML, CSS, and JavaScript, combined with the performance of Rust. One of the most compelling advantages of Tori is its ability to produce native applications with minimal file size, which is particularly important for users with storage constraints or for applications that need to be distributed efficiently. To support the back-end logic and performance-critical features of our application, we employ Rust. Rust is a systems programming language known for its emphasis on safety, concurrency, and zero-cost abstractions. It delivers the performance of low-level languages like C++, while eliminating common bugs such as null pointer dereferencing and data races. Its integration with Tori allows us to write back-end logic that is both powerful and memory safe. Rust also contributes to overall application stability, ensuring that even under heavy load or unexpected conditions, the system remains robust and reliable. For developers, Rust's rich type system and compile time guarantees reduce runtime errors and improve code quality, which is crucial when working in environments that demand high assurance. Together, these four technologies form a harmonious stack that aligns with our project's goals: intuitive user experience and strong performance. React and Next.js ensure a seamless, interactive front-end experience for our users. Tori and Rust empower us to deliver this experience in a compact, secure, and performant desktop application. This combination not only supports our current project needs but also provides a future-proof foundation for scalability and innovation. Thank you very much for your time and interest in our project. We hope that we have shown you just how impactful this experience has been for us as a group and as individuals.